from this week, okay, we're going to move on to chapter 9. Chapter 9 is the last chapter. And we plan to spend this week and the next week. Then we are going to finish the whole chapter 9. The remaining time, we'll be using the time to review all the contents that we have learned this semester and prepare for the final exam. Okay, so what we are going to do today, we are going to work on two topics. The basic idea is we are going to go back to the quadratic equation. And let me highlight the title. This is not new to us. Think of what we have done in chapter 6. We have actually learned how to solve the quadratic equations. But the quadratic equation we saw then in chapter 6, they are actually special quadratic equations. Why? Because we were able to factor the left side of the equation when we say 0 on the right. Then we use what we learned in chapter 6. We factor the equation, and then we are able to get the two solutions of a general equation. Okay, but this is not always be true when we see the quadratic equation. So what does the quadratic equation mean? The quadratic means we'll see a square term. So we'll see a power 2, and then the unknown is staying inside of the base. So in one word here, we'll see the unknown, but the unknown belongs to the base of a power of 2 term. That is called the quadratic equation. What we are going to do in chapter 9, we will learn to solve any quadratic equation, no matter we are able or we are not able to factor the left side of the equation, and we will be able to solve all of quadratic equations. Okay, in chapter 9, section 1, we are going to learn the first method. It is called using the square root property. So square root method, square root. How do we solve this type of equation? This is still one type of special equation. So when we see an equation, the unknown x or y, whatever letter we choose, the unknown appears only once. And it only appears only one time, and it within the square term. Then we will be able to solve this quadratic equation using the special method, the square root method. What is the square root method? So it tells we go back to the square root property. We have been told if we have some number squared equals another number. Okay, so this is actually the definition of the square root. So if we have some number, when we raise a square, it equals another number. And therefore, all real number, we'll know this capital A is always a non-negative number. It's always greater than or equal to 0. Okay, and then we see A is equal to square root of A. And this is what we did before. A is called the square root. But the actual case is this. A is equal to either positive or negative. When we raise a square, no matter it's positive or negative, we'll always end up with a positive number. So this is what we will be applying here. When we see something squared equals another number, then the base is always equal to either. So there will be two roots here, and the positive or negative square root of A. What we did before, we simplify the radical expression here when we only keep the positive square root. So that is actually called the principal square root. Okay, and when we are solving equation here, we will not only keep the principal one, and there is another square root. A is either positive or negative square root of A. Okay, so then let's look at one equation. we see we see the equation a lot of times before. Okay, so this is what we are given. We are asked to solve x squared equals 25. This equation, we have seen it before. So use what we have learned in chapter 6. Let's see, I know this quadratic equation. I know that I can rewrite it to move all the terms to the left. So this is what we did before. We got x squared minus 25 equals 0. And then we can factor it. The factor left side, squared minus squared. Then we get x plus 5 times x minus 5 equals 0. When we got the product equals 0, we let each factor be 0. So x plus 5 equals 0 or x minus 5 equals 0. And from x plus 5 equals 0, we get x equals negative 5. Or x minus 5 equals 0, we get x equals positive 5. Okay, so that's the two solutions for this quadratic equation. This is what we did before. Use what we learned in chapter 6. We were able to solve this equation. Now let's look at the equation again. Use what we just learned. We said, oh, this is a quadratic equation. We know that. And also we know the unknown x appears in the square term. It only appears once. See, x only appears here and it belongs to the square term. It has a power square here. And we know we will be able to use the square root method. The square root method tells us when we say x squared equals another number, then x will be equal to either positive or negative square root of this number here, 25. Okay, so we are not done yet because now we see the square, the radical term, all radical terms, they should be simplified. And square root of 25, we know 25 equals what? Equals 5 squared. So we'll only look at this radical expression here. Radical 5 squared equals what? Equals 5. So this equals either positive or negative 5. So x equals, there are two numbers, positive 5 or negative 5. Same answer here. All right, so that is, so you'll see the difference. See, it's up to you now. We have gained a lot of skills. When we are given one equation, we can use our own, favorite method to solve the equation. It's totally up to us. Does not matter. Okay, so this is one example. You say, oh, barely, I don't see too much difference. Okay, either way, we'll be able to find the solution very quickly. Now let me give you another one. See, if I give you another one here, it gives us like x minus 2 squared equals 25. Okay, so this is the equation we are given. Now, if we use what we learned before, we know, oh, this is a quadratic equation, but there is a parenthesis here. What do? We have to remove the parenthesis. So let's use the old method. So don't forget the old method. Anyway, okay, if you know one way, you'll be able to solve the problem. How do we do this? Remove the parentheses. X squared, raise the power, raise the square to a binomial. It's the square of the first term. Double their product. Negative 2x, double 8, negative 4x. Then plus square of the second term, plus 4 equals what? Equals 25. So what I did here, I have removed the parentheses in the equation. Then what I do next, so this is one typical quadratic equation. I want to say 0 on the right. Then I will move 25 to the left. Then the equation turns into x squared minus 4x plus 4 minus 25 equals 0. Then combine like terms, x squared minus 4x minus 21 equals 0. Okay, then we see a trinomial on the left side of the equation. We try to factor it. 3, 7. We got 21. 3 and 7, we can get 4 here. So the two numbers we'll be using will be x minus 7 and x plus 3, because 3 times negative 7, negative 21. 3 plus negative 7, that's negative 4. So this is what I did. I used method in chapter 6. Then what do we have here? We get x minus 7 equals 0 or x plus 3 equals 0. Then we got x equals 7 or x equals negative 3. Okay, problem solved. See, we have used these many steps to get the two solutions. Now I want to show you, okay, when we see that equation now, when we go to chapter 9, I notice this is a special type of quadratic equation. How special it is? Okay, we see x only once. X only appear one time here, and x belongs to the square term. So in that case, what I do now, I will use the method we just did. So I know something, whatever the parentheses here, something squared equal 25. Then the base is x minus 2, will be equal to either positive or negative square root of 25. So we know that square root 25 equals 5. That tells us x minus 2 equals positive 5 or x minus 2 equals negative 5. I split the two cases, keep the positive, so x minus 2 equals positive. We all know radical of 25, that will be 5. So positive 5 or negative 5. Then what do? We are going to solve this linear equation. Plus 2 on both sides. I get the x equals 7. Or plus 2 on both sides here, I get the x equals negative 3. Done. See, we got the same answer here, but if we use the square root principle on this equation, I believe we could save some time. Okay, so this is the comparison, and still you can go either way to solve the equation, but now we have multiple tools. When we have the special equation, x only appears once in the square term, then we can use the square root method. All right, so this is like the advantage of this method. We can speed up to solve solution. And there is actually another advantage of the square root of equation. Sometimes, look at what I have here. I have another example, x squared equals 20. Okay, so if we use what we did before in chapter 6, I see, okay, I see this quadratic equation. I will move everything to the left side. I get x squared minus 20 equals 0. And then what can we do now? We cannot move on because we cannot simplify the left side. Let's say we cannot factor the left side. Why? Because this binomial is prime, because 20 is not a perfect square term. So if this problem is given to us in chapter 6, we'll give up. We don't know how to move on. So have the left side, this binomial cannot be factored. We cannot solve it. All right, so now we are in chapter 9 now. So we are given the problem. Square of x equals 20. Special type of quadratic equation. X appears once and it belongs to square term. And then I know I can get x, so the base number, whatever the base is as the x for this problem. So base equals what? X equals either positive or negative square root of 20. And we are almost there. So we know, well, at least we know what x is, but to make sure we have the final answer, we just simplify the radical expression. If you want, you can move to the square, the square paper. Okay, so radical 20 equals, recall what we did in chapter 8. Now we go back to chapter 8. How do we simplify the radical expressions? Factor the radicand. 20 equals 4 times 5. What is 4? 4 is 2 squared times 5. So 2 has square, so 2 can be moved to outside and we'll have 2 only. 5 has to stay inside 2 radical 5. So having this in your mind, you can do this. Okay, you can do the mind calculation, or you work on your scrap paper. Now we go back to the original equation here. I know x equals either positive or negative 2 square root of 5. Final answer. See, we have solved this quadratic equation, which we were not able to do that in chapter 6. And this is the another advantage of the square root method. What we have to remember when we use this method here, don't forget when we take the square root, we'll have the 2 roots, either positive or negative. The other one, do not forget to simplify the radical expression. Okay, what we have learned previously, they can all be applied to what we are doing now. In chapter 8, we know for all radical expression, we have to make sure they are simplified. Same thing here. So this is another example. All right, so I hope you can get the method here. This method is called square root method. Let me see. Okay, if I have another example. Okay, I think that should be it. To just remember. Okay, so this method is applied, can be applied to this special type of quadratic equation. This is chapter 9, section 1, using the square root method. Oh, one more example here. Sometimes, okay, for example, we are given one equation here like this, for like 4x squared equals 40. And we'll see, yeah, x appears only once in the equation and x belongs to the square term. The problem is the square term has one coefficient. So to solve this equation here, so for any equation like this, we are going to isolate the square part of the term. So I got 4 times x squared equals 40. I will solve for x squared first. How? Divide by 4, divide by 4. So 4 divided by 4, 4 is gone. I get x squared equals 10. After I get x squared, then what do? I get x equals either positive or negative. Square root of 10. Square root of 10 cannot be simplified. This is one simplified version of the radical expression already. So x will be down. X is either positive or negative square root of 10. So sometimes when we are given one equation, we might add one more step. Solve for the square term first, then take the square root, either positive or negative. I think this problem covers all the types of equation that we will see on the final exam, on the next quiz, or on the homework. All right, so I will stop recording for this section.